Hey guys, welcome to Tech Learnings. Today we are going to learn about JVM, which is Java Virtual Machine. We all have written Java programs and executed our code, right? But how internally the code gets executed, right? We know, I think probably most of us might have heard of JVM. So what exactly is JVM? What is the role of JVM in Java? And how is JVM, or what JVM is exactly made up of? Means what is the internal architecture of JVM? So all those things, and how our code gets executed, the bytecode, how it is executed by your JVM. So we are going to learn about that. So since the content is a lot to understand, so I have segregated this video into two parts. So today we are going to learn about JVM and the basics of it, and we try to we'll try to dive into a bit more in-depth details, but in the second part of this we'll try to explore more in depth about JVM. Okay, so let's get started about JVM. So as I said, that JVM stands for Java Virtual Machine, and it is a part of JRE, which is Java Runtime Environment. All right, so if somebody asks you what is the difference between JRE and JVM, then you can simply tell them that JVM is actually contained within JRE, right? So JRE is made up of two things, basically your Java APIs, which are your you can say the built-in libraries or classes or tools that are given to you, and your JVM, which is Java Virtual Machine, right? So JVM is actually a part of JRE only. Now what about virtual machine? Why we are calling it a virtual machine? Let's separate the word. Let's cut the word Java out of it. So what is a virtual machine? Virtual, as the name also says, that it is something which is not physical, right? For example, we have our desktops, they are physical machines. We have our a laptop, which is a physical machine. But JVM, or you can call a virtual machine, is something which is an entity which is not physical. It's a software entity, right? So what is JVM? It's a software implementation of machine, and it's a Java machine. It's a Java software. It's a piece of code, Java software, right? So what is the role of JVM? Next thing. So I've written down certain pointers out here so that I can explain in a sequence, basically. So role of JVM, primary, the prime responsibility of JVM is to read the instructions, read the bytecode, and then execute that bytecode. We'll know more about it as we progress further, that how JVM performs its task. Alright, so for now, JVM, what it is, what is the purpose of it? Because we know that a Java compiler produces bytecode. I hope you know what is exactly we mean by bytecode in Java. So role of JVM is to read that bytecode, read the instructions which are there in that bytecode, and then execute them on a machine. All right. Now, another thing before we progress further is JVM platform dependent, or it is platform dependent? We know that Java is a platform independent language, right? So you have bytecode. That bytecode can be executed on any machine, right? That's what we call platform independence, right? It can be executed on any machine irrespective of the hardware or software which is installed on that machine. Now, is JVM platform independent? Basically, the answer is no. We have Java runtime environments for created for different machines, like or different architectures. You can say you have JRE for Windows, JRE for, in fact, JRE for Windows 32-bit, 64-bit, and then for Linux, for Solaris, for all different operating systems we have different JREs, right? So it also means that we have different JVMs for different machines, right? So it is not something which is platform independent, but rather created by it is created as per that machine, or as per that operating system. Now another thing before we move on, that JVM, basically the specifications of JVM are provided by Java, but it is not that only Oracle is the creator of JVM. There are JVMs, like for example IBM has created their own JVM, right? For example, Google, the Darvik JVM, it is also a JVM, right? So there can be different vendors of JVM, like because Java is like open source, right? So anyone can create the runtime environments, the JVMs. But yeah, there are certain specifications that you need to you can say that you need to follow. Alright, so the features of JVM, let's move further. So it's a stack based, you can say, architecture. It uses, like unlike the common processors like Intel processors, they are usually register based, right? If you see the internal architecture of JVM, it does use the program counter register. We'll know more about it, but and the working wise, I would say the JVM is a stack based entity. So it uses a JVM stack. Again, we'll know about it as we move on. So JVM is a stack based entity. Then symbolic references, we know that Java does not contain the concept of pointers, right? It is not storing the memory addresses, rather than it stores the symbolic references. So JVM uses those references while doing its task. All right. Then automatic garbage collection, I think if you read about the features of Java, then it is again one of the core features of Java, that it performs automatically the garbage collection, and JVM does that for Java. JVM uses network byte order, right? So in order to maintain the sequence, means the bytecode sequence must be maintained in order that it is executed properly. So JVM uses a network byte order, right? The same order that is used to transfer the bytes over network. So JVM uses that as well, network byte order. Then it guarantees the primitive data type sizes. Like if you have read about C, then in C we have different sizes. Like for example, an int data type, it has different size. Like for one machine it has, or one architecture it has, let's say 2 bytes, and in another architecture it has 4 bytes. So JVM ensures that your primitive data types, like for example your int or any other data type, they basically occupy the same size in each machine. Alright, so it's again the responsibility of JVM to guarantee the size of your primitive data types. So these are some of the features of JVM. Now like this I have already told you, so JVM is open source, and any vendor can create their own JVM. So Google's Darvik virtual machine, or IBM's virtual machine. So these are, so it's like I said, Java is open source, so every vendor is actually eligible to create their own virtual machines. Now for the next one is Java P example. So it's a tool basically that is given to us, and for that we need to create a class. Let me just quickly create a class for us. Let's say I write class hello, and public static void main. I quickly type it, and let's say system dot out dot println hello Java. So I save it. Let's say I save it in C TL projects, and I save it with the name hello Java. Okay, exists already, no issues. We replace it, and alright, let's quickly compile it, and let's try to run it as well. Cool. So now coming to the Java P utility, basically we know that, right, the Java C is in the Java compiler, and it is going to produce the bytecode. Now if we see the bytecode here, that let me try to open it. Let's say notepad. Now it's not something which is human readable. These instructions are not supposed to be read by human, and of course they are not human readable as well. So this is something which the JVM is going to understand, right? So JVM understands this bytecode. Now Java tool is another tool which invokes your JVM, and then and JVM does rest of the task. It executes those instructions and then produces the output head of Java. Now we are going to learn about one more tool, Java P, which is basically a kind of de-assembler, right? So if we want to deassemble our class, what exactly is contained in the dot class file in human readable format. So we can see here Java P hello, and it is compiled from hello.java, which is fine, and it is containing a class hello, and it is containing one constructor and a one main method as well, right? And then it has multiple options, like for example one is -c. In a more detailed view, if you want to see the instructions, so this is the constructor and this is the main method, and what exactly in these are, so these are byte numbers, these are the byte numbers, and um, okay, so 0 1 4 0 3 5 8, and why is not there a sequence, like where is 2 here, where are 2 and 3, in fact where is 1 and 2 here? So these are, first thing is that we need to know is these are byte numbers. So every bytecode instruction is having a byte number. Now these what is a load underscore 0, invoke special, return, get static, these are the operation codes, op codes. Alright, so JVM is going to read these op codes. Alright, so invoke special, return, so these get static, these have their own meanings, return, which the JVM understands. So for now these are byte numbers, and these are op codes. Now coming to the point that where are like for example here invoke special, after invoke special there is return, and we have 2 and 3 are skipped here. So basically the reason is these op codes are going to have, these are like instructions, right? So they take operands. So those operands can be of different sizes, like a load, this opcode does not need an operand, so we have sequence 0 and 1, but invoke special, it contains, or it takes an operand which is of 2 byte numbers, so 2 and 3. 2 and 3 are, that is why skipped, because those are occupied by the operands of this instruction. Same return, same way get static, so it is 2 and 3 are skipped because that are occupied by the op codes, not op codes, operands. All right, so these are op codes. So op codes and operands are collectively, you can say, the executed by JVM, and these are byte numbers. All right, so this is how you can you can say decompile your .class file, how you can see what are the instructions that are present in your .class file in a kind of human readable format. All right, so this is about Java P example. Then next we have the internal structure of JVM. So and the JVM is containing basically of three things, I would say. One is the class loader. So the responsibility, as the name also says, it's going to load your byte code into the JVM memory. All right, so there are in fact different class loaders like bootstrap class loader, and then your system loaders, your application loaders. So the whole purpose or the whole idea of this component of JVM is to load this bytecode into the memory. All right, into the memory of JVM. So this is about class loader. So we this structure, like I said, we are going to discuss more about it in depth in the next part. Then JVM memory, or also called your runtime data areas of JVM, it's basically the different areas in which you can say the into which the JVM memory is segregated. The JVM memory is segregated into different areas. Like one example, one thing is heap, the runtime constant pool, and the method area, PC register, the program counter register, the JVM stack, the native method stack. So this is about the JVM memory. We are going to learn about each of these in detail in the next part. All right, I think most of you might have heard of these terms. Heap, right? We are uh, I think we all are aware of heap, where the objects are going to reside, the runtime constant pool. If you have heard of string objects, right? You might have heard of this term, runtime constant pool, then method area, and JVM stack, native method stack. Like I said, we'll discuss all these in detail in the next part. Then execution engine is basically so once your class is loaded in the JVM memory, right? So there some part will be in method area. Then as per like the execution starts by the execution engine. Once the class once the bytecode is loaded into the JVM memory, the next role is of execution engine. All right, so it is going to see what is the opcode, what is the operand, and then execute that bytecode instruction. All right, so another thing is here is that the execution engine, right? Basically our the point here is that your computer understands machine language, right? So your bytecode instruction is converted into your machine language instruction by the execution engine. All right, so that those instructions are converted into the machine language and then executed by the execution engine. All right, so JVM is composed of, we can see here that primarily three things. One is class loader, the responsibility of which is to load your bytecode into the JVM memory. Then JVM memory is made up of different segments, I would say, like heap, runtime constant pool, method area, register, JVM stack, and your native method stack. All right, and then the third thing is execution engine, which is responsible for execution of your bytecode instructions. All right, so for now, I hope this much of information is sufficient, and you can now tell anyone how JVM basically works, what is the role of it, what it is actually made up of, and right. So this is about JVM. The Java virtual machine, and we'll learn more about it in the next video, especially these JVM memory, because these are something which are important to know about execution engine, like for example the terms like you might have heard of just-in-time compiler. So what is that and what is the role of that? Different class loaders, like I said, application loader is there, your bootstrap class loader is there, how hierarchical structure is maintained by class loaders. So all these information, all these details we are going to learn about in the next part. Okay, so thank you so much for watching this, bearing with me so far, and I hope you got an idea of the Java virtual machine. See you in the next video. Take care. Bye.